Now we're going to look at some problems where we're given an equation, or what they call a polar equation, and we want us to change that equation to rectangular coordinates. Now common sense might say r equals 7 for polar coordinates. R is like the radius, so well, let's go ahead and work this out mathematically, then I'll explain how it makes sense. So once again, what we're going to use now, if you go to your formula sheet and you look in the section rectangular and polar coordinates, we're going to use some of this stuff. In this case, I want to use this right here. R equals square root of x squared plus y squared. So that relates R to x and y. And that's in a sense what we want to do. We want to rewrite this equation and not have R there, but somehow convert it to x and y. So the way we can do that is, if R equals square root of x squared plus y squared, let's just replace R with 7. Now you may not know this, but if you remember back some geometry stuff, I'm going to square both sides of this. So 7 squared is 49. When you square a square root, now you know what this is? This is actually the equation of a circle with the center at 0, 0, the origin, and the radius, the square root of this, because the equation of a circle is x squared plus y squared equals r squared, where r is the radius. So what we have a circle with a center at the origin and has a radius of 7. So I'm going to look at my choices there. Circle with the center of 0, the radius 7. And then you can look here, that's one of these two pictures. You can look a little closer. So that one wasn't too bad. Here's the next one. So once again, polar equation. So theta equals 2 pi over 3. And we want to somehow rewrite that with x's and y's. So how would we do that? Well, from our polar, here's an equation that relates tangent of theta equals y over x. So here's theta and y over x. So let's look at using this. So if I say, one of my formulas is like this. How about I take this equation and let's take the tangent of both sides. So in the world of math, you can do anything you want to an equation as long as you do the same thing to both sides. So let's take the tangent of both sides. Now the tangent of 2 pi over 3, we can go to the unit circle and say, well, what's sine of 2 pi over 3 over cosine of 2 pi over 3? Sine of 2 pi over 3 is square root of 3 over 2. Cosine of 2 pi over 3 is negative 1/2. So it's actually negative square root of 3. But you know what? So here's what I got. Tangent of theta equals negative square root of 3. But how about instead of tangent of theta, I replace it with y over x? Now, multiply x by both sides. Now, in the world of algebra, this would be called linear equation. It's a straight line. You would call this the slope, and since it's negative, it would look like a line like this. Now let's see what kind of answers they ask for. The slope-intercept of that equation would be just what I said a minute ago. It's just right here. Y equals negative square root of 3 times x. And then what's the graph of the equation? It's going to be some kind of a straight line like this. So which quadrants is it going to be? Well, actually, let's go back to 2 pi over 3. 2 pi over 3 is right here. So if you think of this line going like this, it's definitely going to be in quadrants 2 and 4. So it's got to be A. All right, and the last one like this, problem 16, this is probably the trickiest one of all, where the polar equation is r equals negative 10 cosine of theta. So once again, we want to rewrite all of this to just have x's and y's. So sometimes this is like just little tricks you learn. So for this one, little trick you learn is I'm going to multiply both sides by r. So over here is r squared. I'll move the r in front of the cosine, minus 10r cosine of theta. But now, if you look at the formula sheet, you remember r is the square root of x squared plus y squared. Well, if we were to square both sides, actually r squared is x squared plus y squared. If you also look at the formula sheet, x equals r cosine theta. So let's put this in for r squared. And let's substitute r cosine theta for x. Now you may not recognize this right away, so now we're going to have to do some algebra. And here's how you do this. You have to do this thing called completing the square, which is something you learned in algebra. I'm going to get everything on the left-hand side. So I'm going to add 10x to both sides. And I'm going to do this thing with the x's called completing the square. So I don't have time to teach you how to do it, but you should know this. Completing the square means you take the 10 and you divide it by 2 and you square that. So that's 5 squared. So I'm going to add 25 here, which means I have to add 25 to this side. Now this becomes what's called a perfect square trinomial, and it can be factored. You take the plus here, you take the square root of 25, and it goes here. Now this is something that might be a little tricky, but actually this is the equation of a circle. And the center is at -5, 0. and the radius is going to be 5. So this is based upon remembering the equation of a circle. So that may be asking a lot for people, but that's how you have to do this. So that's why when you look at the answers, I mean, the equation you're going to type here is this right here. That's the equation. And they say, what is it? And like I said, it's going to be a circle with the center at -5, 0. So it would be B right here. And then looks like A would be the actual graph. All right, the last one's a little tricky, but sometimes they'll give you those.